This video is on polynomial functions, and when we talk about polynomials, where we're headed with it is just the idea that we have usually a variable of x or whatever it happens to be, and it probably has some sort of multiple term situation. So we'll have maybe something with 4x to the fourth, and then maybe we'll have 3x to the sixth even. We could have something, a monomial or a single component could be as small as maybe I had 2, that's a constant, or 3x. Let's just put some signs in front of these and talk about standard form for a second. When we talk about standard form, we like to have everything organized in a way where we can make comparisons between them. A standard form, essentially, as far as polynomials goes, represents the idea that exponents on the variables descend, which is to say they go down over time. So what I want is to find the term that has the highest exponent on the variable, so in this case x to the sixth, and I'm going to put that one first. So for this one I would make it negative 3x to the sixth. I meant to turn this into green, I don't know why that didn't work. And then I would just make sure that I find the next smallest one, or the next one down, next largest one I guess, which would be 4x to the fourth, so plus 4x to the fourth. And then I'm going to deal with plus 3x because it's next, and then minus 2 because really the variable here would be x to the 0 power, anything that's a constant, because x to 0 power is just times 1. So that's the thing you want to put last. Standard form, have the nice exponents going down, descending fashion, kind of like those little Russian dolls that hide inside each other. Now, when I say the word degree, what I'm talking about is the largest, the term that has the largest exponent on the variable. So if I have 15 terms, maybe the largest one is x to the eighth. The degree of that polynomial is x to the eighth. And we can name them or organize them in such a way that it makes it easy to classify them, which is really sort of to name them. For instance, if I have 0 degrees, so maybe I have just a number like the number 5, I generally refer to that idea as being a constant function, because it's going to draw like a nice solid line. If I have a x to the first power scenario, and that's the largest one that's there, I'm going to say it's linear. If I have x squared involved, I'm going to start looking at that as a quadratic. If I have x to the third and some other stuff, dot, 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 plus minus, as long as x to the third is the most, I'm going to say that it's cubic. If I have x to the, x to the fourth plus x squared minus 1, or whatever it happens to be, I'm going to go ahead and refer to that as a quartic. And then finally, if I have x to the fifth, I'm going to consider that to be quintic. And it goes on and on and on. At some point, it ends up being that they refer to things as like degree of and the number. There's no prefix after a certain point. Usually around 5, they stop using a prefix, but occasionally people throw some other things in there just for whatever it happens to be. A polynomial can also be defined not only by its degree, I should say, but also by its number of terms, like how many parts there are. If I have 4x squared, there's only one term, no matter despite the fact that it only has one component to it. So I'm going to refer to that as a monomial. So it's almost like first name, last name. I would say it's a first name and then last name relationship. If there's 2 parts, so say 4x minus 9, then I'm dealing with a binomial. If I have 3 parts, I'll use one of the ones from the other side. I'll say this is a trinomial. And then I start getting into 4. I'm looking at polynomial of 4 terms, and it tends to break upwards from there, of 5 terms, of 6 terms, of 7 terms. We don't tend to continue making up prefixes for them. They're just not very well done at that point. So that's classifying them. So let's use it to practice a little bit. So in these, we're going to put them in standard form, and then from there we can go ahead and classify them based on what they are. So I notice that this is the first term here. Yeah, flip over to blue pen. This is my largest term. This is x to the first power. This would be x to the 0 if I so desired. So to write it in standard form, I would need to write the x squared term first, keeping the sign with it, plus 5x minus 7. Now, the degree of this one, so degree of the polynomial is the 2 there, because that's the largest. X squared is the largest. And the number of terms is, of course, 3. So taking what I had before and putting it together, that would mean I would end up with a quadratic trinomial. So that's that. Let's look at the next one. Once again, I want to take a look at them in terms of what their degree have. What's the largest degree? And that would be right here, x to the 4th power. So I'm going to put that one first, 6x to the 4th. If this was a minus 6x to the 4th, I'd put a negative in front, just FYI. You'll notice that there are like terms. We do need to combine those to get them in full-on standard form. So 4 minus 3 gives me 1. So plus 1, x to the 3rd. X to the 2nd power would come next, minus negative 2x squared. There is no x term, or x to the 1st power, so I just don't have to write that. And then plus 16 tags on to the end. Now, from a degree perspective, I could say that the degree is a 4th degree, and number of terms I would say that we have 1, 2, 3, 4 terms. So the gigantic name that sort of tags itself onto the end of this behemoth is, we're dealing with a quartic polynomial of 4 terms. So that's naming them and classifying them.